Hello viewer, thank you for coming back to my channel to watch the video tutorials that will help you in preparation for your exams. Alright, now in this question I and j are horizontal unit vectors directed due east and due north respectively. The portion vectors are given relative to a fixed point or origin O. At 9 a.m. the ship S leaves a harbor and moves with a constant velocity of 10 I plus 15j kilometers per hour. Find the exact speed. Now this is a good question. I'm going to break this one into parts so that at least we can be able to get a nice working space. Alright, now let's start with this. Good question. Now getting the speed of S, not F, sorry. We just need to do speed is equal to the modulus of the velocity vector, which is going to be the square root of the I component squared plus the square root of the j component, the j component squared, not the square root. So you just do them separately and then you get the square root. So this will be the square root of 325, which is giving the answer. When you simplify it, it gives you 5 root 13, yeah, 5 root 13 kilometers per hour. Now let's go to the second part of this question. Yes, and then okay. Now in this question, we are told that a harbor leaves the origin O. At 9 a.m. a boat leaves the point with position vector 50i plus 10j and moves with a constant velocity of that. Find the direction in which B is moving, giving your answers a bearing to the nearest degree. So B was somewhere here. This is the position. This was the position of that particular point. We don't need to worry about the position. And then from this point it was moving 8 units to the left. So this is a negative 8. So you can say 8 units to the left and 10 units up. So I mean now B is somewhere here. So this is 10 units up. We need to get this angle here. So that angle theta is going to be given by tan inverse of 10 over 8, which is giving you the answer. Okay, let me just get it. That is 51.34. Now since we are getting the bearing, if you draw another line here and then we measure clockwise direction, so this answer here, it's going to be, this is 90 90 90 plus 51.34. so this, the bearing now is going to be 270 plus 51.34, which is going to give you the answer 321 degrees in exact form. That's the answer that's required, not in the exact form. This is an approximate. Nice. Now next part, we are having the third part, that is part C. We need to show that these points are not colliding. Right. Now we may need some parts of this question. We may need, let me just import them as well. We may need some parts of this question. That is we have 10i plus 15j, that was the portion of the ship. So OS, it is 10, 15, or simply just 10i plus 15j, just to confirm that it's correct. So that was the point. Okay, that's good. And then what else we may need? The position of the boat, that is 50i. So can say OB, this is 50i, then 10j. Then the constant velocity, let me say constant velocity of the boat, or VB. Constant velocity of the boat is constant velocity of the boat is -8, 10. -8, 10. This is a -8, 10. So just a point of correction, this is not the point, this is the velocity, the constant velocity of the ship, not of the boat. Take note of that, please. Yeah, it was given in kilometers per hour, as you can see over here. This is what it was. Right, now any other information? I think we are good to go to get SB. T hours after 9 a.m. Now show that at time t hours after 9 a.m. SB is given by that, so we will need to get SB t hours after 9 a.m., which is going to be the initial position. So this is like OB minus OS, and then OB t hours after 9 a.m. it was the initial portion of the boat, which was 50i plus 10j, then plus the constant velocity times time, so that is -8, 10 multiplied by t, and this is going to give us 50 minus 8t, then 10 plus 10t. That is it. And then we also need the position of the ship t hours after 9 a.m. Yes, so meaning that we're going to have the velocity, the constant velocity of the ship, which is 10:15, multiplied by time, which is giving us 10t, 15t. Now we can substitute it in our formula. SB will now be given by OB minus OS, of which we already have our OB, that is a 50 minus 8t, then 10 plus 10t, then take away, that is a 10t, 15t, so 10ti plus 15tj. So this is going to give us 50 minus 18t, then here we are going to have 10 minus 5t. Therefore, in terms of ij and t, we can now say that our SB is equal to 50 minus 18 t I plus 10 minus 5t j. So that's what you are supposed to show. So you can just say hence shown, like that. Yes, that was enough to give you 4 marks. Now in part B, you're supposed to show that B and S do not collide. Now I think that should be part B, showing that they are not colliding, not part B. Now S and B collide if the distance between S and B, or let's say the displacement between S and B is equal to 0. Now for us to get a 0 vector, so we can just say that both the I component and the j component are equal to 0. So if we set the I component and j component in SB to be 0, so that 50 minus 18t equal to 0, then we solve for t in this case, which is going to give us 50 over 18, or simply 25 over 9. Then on the other hand, if we do 10 minus 5t equal to 0, this is going to give us t as equal to 2. Now you see there's no time for which these two boats are giving us 0. So these two times must be equal to 0 for us to get a velocity vector of 0. So they are not colliding. So you can just say since 25 over 9 is not equal to 2, S and B do not collide. And that is it. Now finally we will need to address the last part of the question, which is part E. So I'm going to snipe it like that, and I'm going to insert it to the current page. I think it has been inserted in the top. Okay, let me snipe it again and put it on a different page because it's giving it as an overlay. Yes, this is it, to a new page, and then we will need to refer to the previous page. So when B is in the northeast of S, the distance between S and B is D kilometers. So we need our SB. We can get it from the previous page. Our SB is 50 minus 18t. So it's equal to 50 minus 18ti, then plus 10 minus 5t j. Nice one. So we already have everything we need to start that question. Now what happens in this is that if B is in the northeast, I mean, like, let me just model it somewhere here. Northeast is this one here. So any point along this, okay, I think I'm now drawing my things here on this line, I will always be equal to j, and therefore what you're supposed to do is to equate the I component to the j component and find the value of t for which B will be in the northeast of us. So that's what you're going to have. Should be equal to 10 minus 5t. So if you bring everything on one side, 40 will be equal to, so sorry, this one should be 18t. Yes, 18t. So 40 will be the same as 13t. Divide both sides by 13, and then at time t equals to 40 over 13 hours, that's when B is in the northeast of S, and therefore getting that particular distance, we are going to substitute t in the SB, which is going to give us so we can just have in column form. So we are just substituting t in this SB equation here. Then we have 10 minus 5 times 40 over 13. So when you simplify this from your calculators, it has to give you the answer. Okay, let me just get it. 50 minus 18 times 40 over 13 times 40 over 13, it's giving you negative 70 over 3 over 13. I think they'll all give you the same answer. They have to be the same. I component must be equal to the j component, and therefore to get that distance d, we have to do the modulus of SB, which is going to be the square root of, that is negative 70 over 13 squared plus negative 70 over 13 squared, or simply you can just do 2 times negative 70 over 13 squared. It's allowed, it's okay. When you do this, the exact answer that you're going to get to be, so answer squared times 2 then square root of answer 70 root 13, or 7.6123 SF. And that's it for this question